Hey everybody, this is Kuei at Dun. I saw an interesting Stack Exchange question the other day, and it's how can I arrange the database structure for ranking cards in a list in a Kanban board? Now, we recently released a Kanban board in Dun. This was back last November, and this is something that I had debated over for quite some time, and I ended up coming with a solution I thought was actually a little bit surprising. There were a lot of good things that came out of it, and I want to share with you my unique approach to storing sort order in a Kanban board. Now, before I get into all the details, let me just take you through what the Kanban board looks like in Dun. So historically, we've always had all of our tasks in a Dun project as lists. Back in November, we added this new design if you wanted to view your tasks as a Kanban board. So I can just click on this Kanban view on the right, and you can see essentially all those same tasks are now converted across a board. Now for Dun, each of these cards represents a task, and each of the columns represents the status that the task is in. All right, so let's get back to the original question. How would I store the sort order of these tasks in these columns in the database? Now, I'm going to simplify things a little bit, but imagine we have a tasks table and then a statuses table. So a task has a related status ID that's a foreign key to the statuses table. And so that would help us represent pretty much everything we have on the old listing page. But now with the addition of Kanban, we need to have some place to store the sorting. The first thing that probably would come to mind is to have a extra column on the tasks table that is a sort order or weight or whatever you might want to call it. And that would be probably an integer field or some numerical value. And in that field, for instance, if we go down the open tasks here in this open column, you would number these 1, 2, 3, 4, and so forth. And then over here in the in progress column, each of these tasks would also have a sort order value of 1 and 2. And then the way we would deduce that in code is we would be able to query the database, pull out all the cards or all the tasks of a particular status, then sort them by sort order. And actually, if you look at the original poser of this question, that's the approach that this person came up with, essentially having this weight column here. But this person realizes something that you'd pretty soon realize when you're actually implementing this. That sort column gets pretty brittle because if I go back to our Kanban board here, if I continually move items around just in that same column, we would have to either renumber everything every time, starting from 1 going all the way down to however many cards are in that column, or we would have to start essentially exposing decimals. So if this were 1 and 2 and I move this third item over here, now we might give this a sort order of 1.5. And you can see that if we continually move things around, it becomes harder and harder to find a good number that fits in between the other two numbers, and B, eventually you might, if you do it in a certain way, run out of decimal places if you're sort of just blindly adding a new decimal place to make things simpler for yourself. So that approach seems sensible, but is pretty brittle. So that's the first approach. The next approach I thought of is something I'll call the linked list approach. So same idea with having an extra column in the task table, but this column would actually be a foreign key that points back to the ID of the same task table. If you're familiar with the concept of linked lists in computer science, it's having an object that basically has a pointer to another object. And in this case, that extra column would essentially point to the ID of the next task in the Kanban column. I think this is a neat idea from an academic point of view. I think if I were in a computer science class, this might be something I would try to experiment with, but in practice, it actually is kind of a little dangerous. The thing that's a little bit scary about a linked list approach is suppose we just somehow got into a state where task A was pointing to task B, but task B somehow also pointed to task A. Well, when we pull that stuff out of the database, we might get ourselves into an infinite loop. Somebody can also just come into the database unknowingly if we were to do some manual change and accidentally have two tasks pointing to each other. So I really want to avoid that. The positives are it is kind of clean in the sense that you can lean on the foreign key constraint to make sure that the tasks that are being pointed to can be pointed to. But I think that all in all, there's just a lot more dangerous issues with the linked list approach. All right, it's a new day, so a new shirt. So I want to talk about the approach I did take. But before I get into it, one thing I realized as I was considering what the best database approach was to storing sort order, there's actually a lot more places you need to consider the sort order being affected. Up until now, we've just been talking about this idea of moving a card around here, and then wherever you drop it, you'd have to represent that sort order update in the database. But you can also change the sort order, of course, by moving it across to a new column. So not only would this move trigger an update to the preceding column and the cards around it, but also to the new column and the cards around wherever the card was being dropped. If I were to add a new task, where would I put that task? Does it go on the bottom? Does it go on the top? If I were to move tasks, in Dundun, you can move any number of tasks from one project to another and assign it a status in the new project. How do we account for the updates there? If I delete a task, that's another place where I'm going to have to consider sort order updating. And finally, one of the things that you can do in Dundun, in fact, the way most people update statuses in Dundun is they go into the task detail page and then change the column, or rather change the status here. So now that task is now moved to a new column. If we went back to the Kanban board, where do we put it? I desperately wanted to avoid those first two approaches because as you can kind of think it through, there's a lot of places where you're going to have to update the sort order and a lot of various actions that really aren't connected to each other. And that can be brittle. There's a lot of testing to do and then a lot of maintenance. And I could just foresee it breaking really quickly as we add in new functionality down the road. So at this point, we need to figure out patterns. Is there a way we can group these different actions into maybe a couple general patterns and from there simplify how we make updates to the database? So the one little rule that we had in place that really helped out was for any unsorted cards in a Kanban column, we would push those at the bottom of the list and then sort them by the order they were created on. So in other words, if I were to create a new task, and then I would go to the Kanban page for the first time, that task would be at the bottom of whatever column it was in. If I created a bunch of tasks with the same status, we would just push those to the bottom. If I were to update the status of a task in the detail page and not on the Kanban board, that would go to the bottom of that column. So with that rule in place, here's how I'm actually storing data in our database for Kanban. I actually have a brand new table. It's called Kanban column orders. And that table has two fields that are foreign keys, one to the project and one to the statuses table. And that essentially maps to every one of these columns you're seeing here. So for instance, in this particular column, that's the in progress status inside the backend bugs and updates project. In the database, it's represented with that one single record. And then in the third field, the item ID orders field, that's where I store all the cards that would exist in the column. And that's going to be stored as simply a pipe delimited list of task IDs. Okay, so here's where I want to put it all together. So here's our Kanban board. And when this board is loaded, there's several calls being made. But the one API call I want to focus on is this for Kanban call right here. And you can see there's two arrays that are being brought back. One of them is this array called list tasks. And this is just a straight array of every task for this project. So we're bringing back all the tasks to the through this API call, and within a particular task, you get the title, you get the status ID, priority, assignee, due date, all the pieces that are required to manifest these individual cards is in this array of tasks. Now the ordering is entirely separate, so that's a separate array here called list Kanban column orderings, and this really on the back end is just a SQL call that just says give me all of the Kanban column order records by project ID. So it's a really quick, very simple basic call. You can see that when we open up a particular object in this array, there's the status ID being pulled back, and that's coming directly from that table, as well as the task IDs. And these task IDs, you'll remember we store them as a pipe delimited list in the database, and then just on the back end, we can pretty easily convert that pipe delimited list to an array of IDs. Okay, so this is where things get, I think, pretty neat. So we've got this list of tasks, all the tasks in this project, and we can filter out the ones just by status for each column. And we've got this ordering data. So for each status, each column, we've got a list of task IDs ordered in a particular way. So how do we kind of coalesce the two and make the order correct? It might seem pretty easy, right? We've got some tasks for the status and we've got the ordering. We can just rearrange the tasks in the order specified in that column ordering data and we're done, but not so fast. So here's the caveat, and this is actually the reason why I chose this approach over those first two options. The column orders data can actually be stale. Now, of course, if we're rearranging tasks within that column with a different sort, that column ordering has to get updated correctly. But when I say that that column ordering gets stale, what I mean is that there may be task IDs in this column ordering that are no longer part of that status. And that could be for a number of reasons. That task could be moved to a new project, so it's not even part of the project. It could have been deleted. The status could have changed to another status. In all those cases, what I don't do is I don't re-update that column ordering. I actually leave that column ordering as is. Because if you think about it, if we have, let's say, 10 tasks for a specific status, and at some point they were ordered in the specific way, if I took the third task and I were to delete it, and I took the fifth task and I were to change its status, and if I took tasks 7 through 9 and I moved it to a new project, well, the remaining tasks that still have that status are still ordered chronologically correctly, just that we have this sort of Swiss cheese effect where some of these tasks no longer are a part of the status. And that's fine. I don't need to actually go back in and update it for any of those changes. And this is what I'm talking about earlier, where we needed to think about the pattern. So what are the occasions for which the sort order does get affected for this column, yet we don't actually have to make an update? Well, there's actually quite a few. And so in reality, the only time I need to actually make a sort order update is if you're moving tasks within that column around, so I have to re-push the entire stack of tasks in that order back to the backend and save that as that pipe delimited list in the database. Or B, if a task is being moved into that column from another column. So in that latter case, when I move a card from one column to another, the column that the card is being moved to, we have to push that sort data back to the database. But the column that's being moved from, I don't need to touch that. I don't need to update that sort order. I'm going to allow it to have a stale old task ID that no longer exists. And that makes it so that I don't have to update the database in that many places when I'm doing any sort of sort adjustments. In fact, it was just those two I named earlier. Now, what that does mean is that we have to be more prescriptive on the front end when we've got this data to manifest the ordering of the tasks in these columns correctly. So let's move to the front end here. This is the Kanban board component in Vue. Vue is the framework we use to render the front end application. And the first thing you'll notice is that we are using a watch on the tasks array. So whenever that task array changes, we're going to call this refresh columns method. Now the refresh columns method is going to take the statuses. So we have a list of statuses, and for each one, it's going to order the tasks that have that status correctly in that column. And so that's done here in this order tasks in column method that passes in a particular status ID. So this is really where the guts of the ordering happens. So the first step is simply taking all of the tasks in that full tasks array and pulling out the ones that have that status currently. So we know that these are all the cards we need to represent in that column. What I do here then is I sort by the reference number. So the reason we do that is then we're basically sorting it chronologically. The second thing we'll do is then we're going to look at the column order array for that particular status. And as I mentioned before, this array can contain tasks that no longer are part of that status. So we'll just loop through that array, and if we find a match in that filtered set of tasks, we'll push that task into this new array that's going to be the ordered array of tasks. And in this way, we're essentially going to collapse that order into just the tasks that still belong to that status. And then finally, we're going to take all the other tasks that were not represented in that ordering array, and we're just going to push those to the bottom. So this would essentially represent all of the new tasks we created, all of the tasks that maybe had a change of status on the detail page that were never actually ordered, all the other tasks that were not part of the last time we had to push the ordering, go to the bottom, ordered chronologically. And that final set now gives us the correct ordering. Now finally, just to close the loop, here's how I'm pushing that sort order data in those two occasions where we need to update it. So sorting within a column or having a new task be moved into a column. So as I'm sorting within a column, you can see if we inspect the API calls here, this is the put method that we are using to basically re-push this task ID column order. So this is pretty easy to do from the front end, just getting that order list packaged up into an array and sent across to the API. And then on the back end, that's being basically converted to a piped limited list and then saved off into the database. And of course, if I move this, let's move this one over to a new column here. And you can see that it is only that new column for which the order gets updated. In this case, this is the first element, or the first task rather, in that new column. So there's only one task ID being passed over to that column. So that's the approach we took to the Kanban sorting. It's certainly different than what I first thought would happen. And, it just goes to show sometimes in programming, the prescribed way you might think of doing things ends up being completely not the way you do it. I think that a lot of times you have to look at your tool set and look at your trade-offs and decide what is more important to you. And in this case, the ease of implementation, the fact that there's much less of a footprint in terms of where all these sorting updates have to take place, that was to me a huge priority. And of course, we're giving away some things here. We don't really have referential integrity in the database, but I don't think it's actually that critical in this case. In fact, the fact that we don't allows us to do this approach where we have this sort of stale data that we can kind of overcome and patch up once we gather this information and kind of reassemble the sorting on the front end. So certainly some interesting outcomes. I'd love to hear your feedback in the comments below, and hope you enjoyed this.